Let's take a look at section 6.5, Multiplication of Polynomials from your text. And I want to look at 4 problems. These are all from your textbook on page 512 and 513. Let's take a look at number 12. The first thing you need to notice is that we're multiplying a monomial, which is one term, times a trinomial, 3 terms. If you have a monomial times a polynomial, meaning monomial times binomial or times trinomial or any other polynomial, what you need to do is use the distributive property. When we multiply, we take the monomial, multiply it times all 3 terms. You should add your exponents, and so we're going to get negative 2x, add the exponents, 4 plus 3, so 7, negative 2x to the 4th times negative x squared is a plus 2x, 4 plus 2, 6, and then negative 2x to the 4th times 2x gives us a negative 4x to the 5th because there's an exponent of 1 for the x. Then we check to see if we can combine like terms, and since we don't have any like terms, this is our final answer. Moving on to number 20. Very similar to number 12, except we have to use the distributive property twice, for part 1 and for part 2. So let's go ahead and do that. Remember, you need to add your exponents. 4x cubed minus 4x squared plus 4x. That's the first part. Second part, plus 3x squared minus 3x plus 3. Next, you need to look for like terms and combine them. Like terms have the same variable and also the same exponent. So there is no other x to the 3rd. I recopy that. We have minus 4x squared and also a negative 3x squared. We can combine those. We get a negative x squared. When you combine like terms, do not change the variable or the exponent. You are just, in this case, subtracting the number that's next to the variable. We also have plus 4x minus 3x, which gives us a plus x, and plus 3. And then that's completely simplified, and we've combined all the like terms. Okay, next we have number 46. This is a little bit different because if you look at this carefully, you have a binomial, 2 terms, times another binomial. And in this case, what we have to do is use FOIL procedure. FOIL. So we have first, outer, inner, last. So let me show you. We start with the 3x, multiply it with the x, and then take the 3x, multiply it with the 2. So let's go ahead and do that. That gives us 3x squared. Again, you need to add your exponents. Then we have 3x times a positive 2 plus 6x. Next, you need to multiply negative 4 times x and negative 4 times 2. We have negative 4x minus 8. once that's done, look for like terms. They usually occur in the middle, plus 6x minus 4x, which gives us 3x squared plus 2x minus 8. And that's completely multiplied out. Finally, the very last problem, number 60, we have a binomial times a trinomial. So this is slightly different, but you're going to use the same procedure, which basically means you take your x, multiply it with x squared, x times x, and x times 1. And then we do the same thing with the 1. 1 times x squared, 1 times negative x, 1 times 1. And then combine like terms. So let's start that. X times x squared is x to the third. X times a negative x is negative x squared. Still adding the exponents. X times 1 is plus x. Same procedure with the 1. One times x squared plus x squared. 1 times a negative x is negative x. 1 times 1 plus 1. Combine like terms. No other x cubed, so we just recopy that. Then we have minus x squared plus x squared. That's 0. We also have x minus x, which is also 0. And so we are just left with the plus 1, so bring that down, and then we're done. Also, very important, when you are multiplying, you can always change the order of the problem. So really quick, I can also write x squared minus x plus 1 times x plus 1. And I can follow the same procedure, but I can write the problem this way. So the order in which we start with the problem doesn't matter. When you multiply, you can change the order around, whichever is easier. If you look at it this way, you're going to take x squared, multiply it with the x and with the 1. Then take negative x, multiply it with x and with 1. Then take the 1, multiply it with the x and also with the 1. So this is just a different way to look at the problem, but whichever way you start, you have to get the same answer.